Welcome to everybody. So, in this lecture, we are going to study a differential equation of a first order, but not a first degree. Differential equation of first order, but not first degree. So this is the chapter here. Differential equation of first order, but not a first degree. In the last lectures, we studied there the differential equation of the first order and first degree. In this lecture, we study a differential equation of the first order, but not first degree. So what is this equation? What is this equation? Order is 1, but degree is greater than 1. Degree is greater than 1. So what type of equation are these here? So what is the definition? Definition. Okay. A differential equation of first order and nth degree, so higher degree is what? dy by dx raised to n plus p1 dy by dx raised to n minus 1 plus p2 dy by dx raised to n minus 2 and so on pn minus 1 dy by dx plus pn is equal to 0. Okay, where p1 p2 and so on pn minus 1 pn are functions of x and y. Okay, so this is the first order and nth degree differential equation. So why it is called first order and nth degree? Because order of this differential equation is 1. So this is the first order. But degree is n. Degree is n. So the equation is called first order and nth degree differential equation. Where coefficient p1, p2, pn are functions of x and y. Okay. So put here. So denote dy by dx by p. So this is equation number 1. Denote dy by dx by p in this equation. This equation reduces to, or this equation can be written as p raised to n plus p1 p raised to n minus 1 plus p2 p raised to n minus 2 and so on p n minus 1 p plus pn is equal to 0. Is equal to 0. Okay? So put dy by dx is equal to p in this equation. So we simplifies, we write this equation in this form here by putting dy by dx is equal to p. So dy by dx p. So this is p raised to n. So this is p1. This is p. So this p and this p are different here. So we say this p is capital P, this p is capital P, and these are the small p's here. Simply. Okay. So this equation can be written as p raised to n plus p1, p raised to n minus 1 plus p2, p raised to n minus 2, and so on. So this is equation number 2. Okay. This is equation number 2. So this is the first order and higher degree differential equation. So what is the problem? So how to solve, what is the problem? How to solve this differential equation? Okay. So there are three methods. So equation solvable for p. Then this is the first method to solve this equation. Second method, equation solvable for x. And third method is equation solvable for y. Okay. So now we learn here how to solve this equation by using the method solvable for p. Okay. Solvable for p. So method 1 is, here we discuss method 1. Solvable for p. Solvable for p. Okay. So let us consider again the equation. Let us consider the equation p raised to n plus p1 p raised to n minus 1 plus p2 p raised to n minus 2 and so on, pn minus 1 p plus pn is equal to 0. We say this is equation number 1 here. Okay, equation 1. So we can factorize this equation. याचे फॅक्टर्स पाहू आपण. जसं आपण तुम्ही p square minus 5p plus 6. So this is for example here. So this is first order but second degree differential equation. So this is a quadratic equation. So we can factorize this equation, that is p minus 2 p minus 3 is equal to 0. So we factorize this equation because this is n degree equation. So by fundamental theorem of algebra, this equation has n factors. Okay, the equation 1 can be factorized. We get. So this equation can be written as, म्हणजे जसं याचे फॅक्टर हे पाडले तसं याचे फॅक्टर आपल्याला पाडता येतील. ओके, तर ते व्हेरी सिंपल आहे. ओके, दॅट इज p मायनस f1 xy. हा पहिला फॅक्टर. जसं इथं p मायनस 2 फॅक्टर होता आणि दुसरा p मायनस 3 फॅक्टर होता, तसा पहिला फॅक्टर काय, p मायनस f1 xy. Next factor is p minus f2 xy. So how many factors are there? N factors are there. So into and so on, p minus fn xy is equal to 0. So this equation can be written as like that. multiplication of n factors here. Okay, so which gives आता हे आपण सॉल्व करायला काय हरकत नाही. which gives यार p minus f1 xy is equal to 0. p minus f1 xy is equal to 0. p minus f2 xy is equal to 0. Putting this is equal to 0 or this equal to 0 or this equal to and so on. p minus fn xy is equal to 0. Is equal to 0. Okay. So put here again p is equal to dy by dx. For solving, put p is equal to dy by dx. So what happened here? So dy by dx minus f1 xy is equal to 0. Similarly, dy by dx minus f2 xy is equal to 0. And this is dy by dx minus fn xy is equal to 0. Okay. So after putting p is equal to dy by dx, we get this. So solve these equations by using 5 types. So this is the first order, first degree differential equation. We know the 5 types of solving that equation. Okay. So variable separate type, homogeneous, non-homogeneous, linear, exact, and so on. So by using that types, we solve this equation, we get solution. Therefore, these solutions are. Okay, therefore these solutions are. So what happened? So we don't know this function. So we write here. So this is the solutions in f1 x, y, and c is a constant कारण का फर्स्ट ऑर्डर डिफरन्शियल इक्वेशन आहे. याचं सोल्युशन हे मिळालं. f2 याचं सोल्युशन काय? f फंक्शन ऑफ x y constant c is equal to 0. And what is the solution of that? fn x y c is equal to 0. So these are the solutions of this and this. Okay. So we combine that solution. So hence the general solution is, what is the general solution? So multiplying all these solutions, so f1 xy c into f2 xy c and so on, fn xy c is equal to 0. So this is the general solution of this differential equation. बघा इथे काय केलं, याचे फॅक्टर्स पाडले. ओके, फॅक्टर्स n फॅक्टर पाडले, नंतर ते सेपरेट केले इज इक्वल 0. ओके, नंतर पुट p इज इक्वल टू y by dx. ओके, then solving these equations we get this solution, and combining that solution we get the general solution of this differential equation. Let us take an example. Okay, example, very simple examples. We first take simple examples how to solve that differential equation. So example solve p square minus 5p यापूर्वी मी ते दिलेलं होतं plus 6 is equal to 0. Okay, solution. Very simple example here. P square minus 5p plus 6 is equal to 0. Okay, we can factorize this. The given equation can be written as, the given equation can be written as, after factorization, so that is p minus 2. Factors of these equations are p minus 3 is equal to 0. We follow just method. Okay, so this implies that here. So what happened? P minus 2 is equal to 0 and p minus 3 is equal to 0. P minus 3 is equal to 0. Okay, जशी मेथड दिली होती तशीच मी फॉलो करतो या ठिकाणी. इथं फॅक्टर पडत असतील तरच ही असे एक्झाम्पल सोडवू शकतो. फॅक्टर्स पडत नसतील तर दुसरी मेथड आपल्याला फॉलो करावं लागेल. सो पुट p is equal to dy by dx. dy by dx. So we get here dy by dx minus 2 is equal to 0. dy by dx minus 2 is equal to 0. And what is this? dy by dx minus 3 is equal to 0. Okay? So now we solve these equations by variable separable type. Variable separate करून घ्यायची. So we get here what happened here? dy minus 2dx is equal to 0 and dy minus 3dx is equal to 0. Okay? So on integration, then we take integration. On integration, we get here, so y minus 2x is equal to c, independent constant. Okay? And after integration of this, याचं integration, y minus 3x is equal to c. इथं एक लक्षात घ्या, इंटिग्रेटिंग कॉन्स्टंट एकच घ्यायचा, कारण की हा डिफरन्शियल इक्वेशनची ऑर्डर एकच आहे. जेवढी ऑर्डर तितके कॉन्स्टंट. हिची ऑर्डर एक आहे, डिग्री 2 आहे, परंतु ऑर्डर एक असल्यामुळं इंटिग्रेटिंग कॉन्स्टंट आपल्याला एकच घ्यावं लागेल, सी. ओके, therefore the general solution is what? Y minus 2x minus c, multiplying these two solutions here. So y minus 3x minus c is equal to 0. So this is the solution of this differential equation. So this is a very simple differential equation. So now we solve another example. Here. Let us take another example of the same type, solvable for p. Okay. Solve example. Solve x square p square plus 3xy p plus 2y square is equal to 0. Okay, solution. Now we factorize this equation, so we can write this equation in the form solution x square p square plus, okay, xy plus p plus 2xyp. So this plus this is 3. Okay? Plus 2y square is equal to 0. Okay. So we common out xp from these two terms. So xp take common, then we get here xp plus y plus we take common 2y from these two terms, 2y. So 2y into bracket xp plus y is equal to 0. Okay. So therefore we common out xp plus y from those two terms. We get here xp plus y. So into bracket xp plus 2y is equal to 0. So we can factorize this equation in this form. 2 factors पडले कारण का डिग्री 2 आहे. Okay, therefore xp plus y is equal to 0 and xp plus 2y is equal to 0. We solve these equations separately. Okay. So put p is equal to dy by dx. Put p is equal to dy by dx. So therefore we get here x dy by dx plus y is equal to 0 and put p is equal to dy by dx. X dy by dx plus 2y is equal to 0. So by separating the variables, first type by variable separable type, by separating the variables, this equation can be written as what happened here? So that is dy upon y, dy upon y plus dx upon x is equal to 0, and so what is this? Dy upon y plus dx, 2 as it is, upon x is equal to 0 after separating the variables. Okay, dy चा कोएफिशिएंट y पाहिजे, dx चा कोएफिशिएंट x पाहिजे. So on integration we get so what is the integration of this? So this is log y plus log x, integration of this log y log x, taking constant log c. Similarly log y plus 2 log x is equal to log c. So this can be written as log of logarithm rule, xy is equal to log c, and this is what? Log y, it 2 इथं गेलं, log x square, then yx square is equal to log c. So xy is equal to c and yx square is equal to c. So these are the two solutions here. So after combining these two solutions, the general solution is xy minus c into yx square minus c. So this is the solution of this differential equation here. So we take another example. So solve the example of different types here. We take examples of different types. Okay, take the next example. Okay, solve p cube plus 2xp square minus y square p square, y square p square minus 2x y square p is equal to 0. Solve this differential equation. आता हे फर्स्ट ऑर्डर डिफरन्शियल इक्वेशन आहे, परंतु हे बघा डिग्री 3 आहे, म्हणजे फर्स्ट ऑर्डर आणि डिग्री 3 डिफरन्शियल इक्वेशन, त्यामुळे याचे 3 फॅक्टर्स पडणार आहेत. ओके, द गिवन इक्वेशन कॅन बी रिटन ॲज given equation can be written as what happened here? So this equation can be written as, so common out p from this equation, so that is p square plus 2xp minus y square p minus 2xy square, p common out here, is equal to 0. Okay, again p. So common out p from this, common out p from these two terms. So that is p plus 2x, okay, minus common out y or y square. So what happened here? P plus 2x, okay, is equal to 0. So this can be written as P into common of P plus 2x, P plus 2x from these two terms. So P plus 2x into another bracket P minus y squared. जर इथं 3 फॅक्टर्स पडलेले आहेत डिफरन्शियल इक्वेशनचे, मग आपल्या नेहमीच्या पद्धतीप्रमाणे सो P इज इक्वल टू 0, P plus 2x इज इक्वल टू 0, P minus y square is equal to 0. Put P is equal to dy by dx. So this is the dy by dx is equal to 0. So dy by dx plus 2x is equal to 0. So dy by dx minus y square is equal to 0. So this can be written as dy is equal to 0. Okay? Dy is equal to 0. So this is dy plus 2x dx is equal to 0. And what is this? We separate the variables. Dy upon y square minus dx is equal to 0. So on integration. So what happened here? So what is the integration of this? Y integrating on c. That's the integration काय? Y plus x integration काय? X square upon 2. 2 get cancelled. So that is x square c. So what is the integration of this? Minus 1 upon y. And याचं डेरिव्हेटिव्ह 1 upon y square आहे, म्हणून याचं इंटिग्रेशन this minus x is equal to c. Okay? So now we combining these solutions, we get the general solution is the general solution is y minus c. So this is y plus x square minus c. And what is this? X plus 1 upon y plus c is equal to 0. So this is the solution. Okay? So we stop here. तर उद्या आपण दुसरा टाइप बघू. ठीक आहे.